Good afternoon, my YouTube viewers. In this video, we're going to be talking about the central limit theorem. And basically, what the central limit theorem does is it states that for a sufficiently large sample size, the sampling distribution of the sample mean will be approximately normally distributed regardless of the population distribution. So that means that it doesn't matter what kind of distribution you start out with. If you keep sampling it, eventually the actual samples themselves will form a normal distribution. And that's what the central limit theorem states. So what we're going to do is we're going to prove the central limit theorem in Python. And the first thing that we're going to do is we're going to import the two libraries that we need to prove the central limit theorem. And so that's going to be, we're going to import NumPy as NP, which is your numeric library. And we're going to import matplotlib.pyplot as PLT as your visualization library. And then we're going to generate a population data with a non-normal distribution. So this is going to be a uniform distribution. So a uniform distribution is when all of the values are essentially the same. And a normal distribution is what you would call a bell curve. So we're going to we're going to set the seed. So the reason why we set the seed is so every time you run the program, it will initialize to the same values to help you get a good response every time you run the program. And then we're going to set the population as equals np.random uniform brackets low equals 0, high equals 100, and size equals 10,000. And then we're going to set the parameters for sampling. So our sample sizes are going to be a list of 10, 30, 50, 100. And the number of samples is going to be 1,000. So we're going to define a function to plot the sampling distribution. So def plot sampling distribution, and it's going to take the sample size as the argument. The sample means is going to be a blank list. For underscore in range num samples, and that's 1,000. So that means it's going to iterate 1,000 times. Sample equals np.random.choice. So that's your sampling. Brackets population, comma, sample size, comma, replace equals false. So you're not going to replace the values whenever you sample them. And sample mean equals np.mean sample. So that's the mean of the sample. And sample means dot append sample mean. So that means every time you get a sample, you're going to append it to the list of sample means. So ultimately, you're going to get 1,000 sample means in that sample. And then you're going to create a histogram as well. So plt.hist is sample means, comma, bins equals 30, comma, color equals sky blue, comma, edge color equals black, comma, alpha equals 0.7. And plt.axvline brackets np.mean of sample means, comma, color equals red, comma, line style equals dashed, comma, line width equals 2, comma, label equals mean. And then plt.axvline brackets np median of sample means, comma, color equals green, comma, line style equals dashed, comma, line width equals 2, label equals median. plt.title is sample distribution for the sample mean and then the sample size. plt.xlabel is sample mean. plt.ylabel is frequency, and you get a legend and then you're going to show it. And then so now what we're going to do is we're going to plot the sampling distributions for different sample sizes. So for sample size in sample sizes, and plot sampling distribution sample size. So this is the sample distribution of a sample size of 10. And it started out with a uniform distribution, but it looks almost normal. It looks pretty good. You have a mean of 49.38 and a median of 49.76. And then a sampling distribution of 50. It looks a little bit better. A mean of 49.34 and a median of 49.27. A sample distribution of 100, it looks a little bit better. You have a mean of 49.5 and a median of 49.5. So your mean and your median are the same. So we sampled it 10 times, 30 times, 50 times, and 100 times to prove the central limit theorem and to give you the 4 distributions. And you can see as you increase the number of sample sizes, increase the number of samples, then the distribution is going to look more like a normal distribution. And what this code does is it just proves the central limit theorem. So this concludes the video on the central limit theorem. And then what we will do in the next video, we will talk about another statistical concept.